Yeah, so let's talk about logging all the things. And the intro slide should actually look like this, of course. So I'm Philipp. I work at Elastic. I'm in the infrastructure team. And as you can see, there is a pipe, and I kind of pipe the infrastructure work into developer advocacy. So right now, it's conference season, and I'm pretty much all over Europe doing talks. So where can we go from here? Who is already using Elasticsearch? Raise your hand. Very nice. Who is using Logstash and Kibana in addition? Okay, also quite a few. Who is using Beats? That's good. So now we know what we can talk about. Okay, just to get everybody to join in, we'll quickly go over Elasticsearch, Logstash, and Kibana. And then we'll dive down what is Beats, why is there Beats, and what can you actually do with Beats. So, Elasticsearch, you know for search, started in 2010. Our CTO kind of sat in his, I don't know, living room, bedroom, something. He didn't get the proper job, but his wife was a chef and she had lots of recipes. So he wanted to help her, and he wrote something to index her recipes. And she could actually search for all the ingredients she had and find the right recipes. So this is how we started with Elasticsearch. And now it's widely used for full-text search. I guess I don't need to explain any of these logos. So if you're searching on any of these sites, you will be using Elasticsearch in the background. OK, then full-text search was kind of working well. So the next step was to add more products. So Kibana and Logstash joined the family. Kibana is the visualization, so the window into your data, just so you can explore your data, graph it, view it, and see what is actually going on. And Logstash is for the ingesting part, so getting logs, but also other data into your Elasticsearch cluster, and then with Kibana, you can display them. And what this looks like is something like this. So you have the famous ELK stack, Elasticsearch, Logstash, and Kibana. And everybody knows that. And again, this got very popular. Again, 3 examples of what people are actually using it for. For example, CERN, they have thousands of computers, and they need to aggregate logs somehow, somewhere. And the ELK stack is very handy for that. Or Salesforce, with their cloud offering, they are also aggregating all the logs together. And then there is Goldman Sachs. Every now and then, they're kind of doing shady business, and they need to pay a big fine. So at some point, they decided maybe it's a better idea to invest into proper auditing and compliance than to always keep paying these fines. And they're ingesting all the different actions that traders and systems do, so they can have a proper logging and audit trail, and hopefully can avoid problems in the future. So this is all working, and it's working quite nicely. But then this little guy came along. This is Beats, or this was the logo of Beats. And Beat is kind of complementing Logstash. So if you're not so familiar with our products, so Elasticsearch for searching is using Java. Kibana, the visualization, is now a Node application. And Logstash started out as a Ruby application and is running on JRuby now. JRuby is nice. The only problem is it's Java, it's the JVM, so it needs some time to start up, and it uses quite some resources. So some people complained and said, yeah, this Logstash thing is nice, but I don't really want to put that on all my servers. So we need something else. And this is where Beats is coming from. Beats is written in Go, so it compiles down to native system binaries. You don't have any real overhead on that. And Beats is much more focused on different tasks. So we will dive down into these different tasks you can actually achieve with it. But you have different beats for different things you want to achieve. So we had the ELK, and we have Beats, and we tried to come up with something new. So this was the BELK, or the ELK bee. You can still see it's a bee, and it has these ELK horns. Yeah, but it didn't really work so well. So the ELK was retired, and the ELK bee was retired, and now we are just calling it the Elastic Stack. So the new name is Elastic Stack, and ELK, yeah, ELK is not dead. ELK is just retired and somewhere in the background, but it's actually only called the Elastic Stack now. So what the stack looks like today is something like this. You have Beats. Beats are these lightweight agents. They can get some data or metrics, and they can either insert that directly into Elasticsearch, or they can still forward stuff into Logstash. So Logstash can do some processing and enrichment. And then Logstash would store the stuff in Elasticsearch. Enrichment sounds kind of strange. Think of it like you have an IP address and you want to resolve the country behind the IP address. So you can then actually search for all the people coming from a specific country. Yeah, so you have your data in Elasticsearch then, and on top of it you have Kibana. And as you might notice, we have these new logos now, so they're all following our new corporate identity. This is what the logos now look like. So the wooden log for Logstash is gone, and also Elasticsearch has this writing thing is gone, and yeah, Kibana doesn't have the hut or whatever it had. So these are the new logos, and in case we ever want to add new products, they will follow the same corporate identity, and everything is called Elasticstack. It's very easy to actually add products now. And the other big thing is, later this year, there will be a new major release, and it will be version 5 of everything. Because those who are using the Elk stack or the Elasticstack today actually know that version numbers can be quite confusing. So you have Kibana 4.5 and Elasticsearch 2.3. These are the most up-to-date versions. And you always need to look up like, okay, I'm using this Elasticsearch version. What versions of the other components can I actually use? And even for us, it's kind of confusing, and if you're using older versions, we need to look that up in the compatibility matrix ourselves. So we switched version. Version 5 will be the new thing. Everything will be version 5. Why? Because Kibana was at 4.5, so the next available major version is 5. And also Elasticsearch is going from 2.something to 5. So you can see it's getting much more awesome and much more stable and everything, because version 5 is just much more mature. And in case people are wondering, like, where are we actually earning our money? Like, how is my salary being paid? So this is the grander scheme. You can see the Elasticstack on the top left corner, more or less. These are all our open source components, and while some of our competitors have commercial and open source versions of the same stuff, we don't really believe in that. Firstly, because it's a lot of overhead. If you have a commercial version and an open source version, you will probably start testing the commercial version because your customers are actually paying for that, and then you're kind of removing some stuff from that, and you either need to retest it again or you will just throw it out to the community. So that is probably not the best approach. So we don't believe in that. We have, it's called XPack now. These are commercial extensions. So there are features that are not in the Elasticstack in the open source version. And if you want to have them, you can just get them in the commercial version. So if you need any kind of security, authentication, or authorization, any alerting, whatever happened or whatever data you have, you want to be alerted. Monitoring of your cluster or the brand new graph to explore your data. These are all commercial extensions, and they go hand in hand with support. And that is how stuff is actually being paid. And in case you don't want to host it yourself, there is Elastic Cloud. Currently, it's only on AWS. So it's just you have a nice interface, and you click a few buttons, and then you have 5-node cluster in a specific version. And you can just configure snapshots of your data, and with 2 clicks, you can upgrade. This will soon, maybe later this year, early next year, also be available on-premise. So if you have some sensitive custom data, you can run that on-premise, which I think the Netherlands are more open to the cloud, but I'm from the German-speaking world, and there everything needs to be on-premise. Okay, so now down to Beats. Beats are lightweight agents and chippers, and there are multiple ones. So first off, there is Filebit. Filebit is just like glorious tailf. You have a log file, you want to monitor that log file, you point Filebit at it, it will read the file and send over the content to either Logstash or Elasticsearch. and then you can do the enrichment and parsing there. Then, in case you're using Windows, I'm sorry for you, but there is WinLogBeat. It makes it much easier and less painful to actually get the Windows logs. Then there is PacketBeat. Think of it like Wireshark on steroids. We'll dive into that a little later. Then, up until Tuesday, there was something called TopBeat. It was just like the Linux top command, but it was also available on Windows. But on Tuesday, we folded that into MetricBeat, and now there's something called MetricBeat. I'll show you MetricBeat as well. So these beats are provided by us, but you can build your own beats relatively easily. So down there, you see for Apache, Nginx, Docker, Elasticsearch itself, and various other things. There are beats provided by the community, and you can just run them and have everything integrated into the rest of the stack. So Filebit, as I said, it's just like tailf. It can do stuff like multi-line parsing. So if you're, for example, using Java and you have some big stack trace, not every single line is going to be a message sent over the wire, but you can actually group stuff together into a single message and know what was like one error message or one stack trace and have that grouped together already on the host system, so you don't need to send too many packets. MetricBeats is kind of everything containing numbers and metrics. So think about top. You have stuff like CPU usage, memory usage, I/O, how full your disk is, all these metrics, and some other metrics, so you can integrate in other products. All of these metrics can be easily extracted and then sent over to Elasticsearch where it's stored, and we have some pre-built dashboards to actually display that in Kibana for you. I'll show you a quick demo. And then there is PacketBeat. It's simply sniffing network packets off the wire. It doesn't add any overhead. It doesn't add any errors to the sniffing. So it's not really in the part where how the network packets are flowing to your application, but it's kind of copying everything away and then analyzing it in parallel. So you don't add any network overhead. Why don't you just use Wireshark? Well, Wireshark was nice as long as you had 1, 2, or 3 servers. But as soon as the microservice trend started and people started to break out stuff over 20 servers or something like that, using Wireshark becomes quite a hassle, because then you need to capture the packets on many different servers. Then you need to aggregate those packet captures, and only then can you actually analyze them with Wireshark. And PacketBeat is trying to work against that. So PacketBeat will just run on one of your servers. It will actually know like what is a transaction. So it knows, for example, this is an HTTP request and this is the HTTP response. And it knows the request took 100 milliseconds and the response code was a 200. And all of that information is just extracted from the headers. So you don't need to do any customization or anything. This is just available out of the box, and most of the widely used protocols are used. And then there is Lipid. Lipid is kind of the library you can use to build your own beats, and all of our own beats are based on top of that. And you will get some of the default stuff you probably want to have, so to talk to Elasticsearch, or to forward stuff to a queue like Redis or Kafka. All of that is built into Lipid. You don't need to care for that. You can simply use Lipid and write the integrations for your stuff you want to have. And then there are the community beats. For example, execbeat, that's very easy to understand. Every 10 seconds, you want to echo hello world to test host, and you want to store that result. It's not doing much, but you get the idea. Or if you're still using lots of Nagios checks, you can just instrument them and again store those results in Elasticsearch and then display them in Kibana, which might be nicer than what you can do with Nagios. So if you want to check like how much disk space do I have available, you probably want to query that like every hour. That's what the top check does. The bottom one does a load check every minute, and the result is sent over to Elasticsearch and stored there. Okay, now I know talk is kind of cheap, so I can quickly show you a demo. You can just run that on your own. Since it's for all the stuff I'm showing you is the alpha version. There's a branch called v5. This is for current version. What I'm showing you was released on Tuesday, so it's pretty brand new. I hope there are no dragons on the way and everything still works as I expect it to be. And the box is actually working because I just tested some stuff earlier today and I destroyed it, and I could actually just vagrant up the box, and yeah, that's what you'll see. So, switching to the web interface. This is Kibana. For those of you who have used Kibana in the past, some stuff has changed. Firstly, it's a bit more colorful now. Secondly, the menu moved from the top to the left, and you have the stuff you've known from the past. Discover, Visualize, and Dashboard are still there. What was called Sense is now called Console, so this is just nice interface to query stuff. And there is Timeline for time series data, but we probably won't have time for that, but let's see. Okay, so on the Discover tab, I have configured 3 beats on my system to actually gather stuff. So I have Filebit, with which I'm just gathering the syslogs from the local system. I have metric beats, reading stuff like CPU and memory and I/O. And I have packet beat, analyzing all the network packets flying around on my single VM. Okay, so if I run for the last 15 minutes Filebit, you can see I've just had 3 hits. Obviously something happened there, and I've expanded something here. I can see, okay, yep, there was something, an hourly cron job, it landed in syslog, and yeah. All the stuff like, where did it come from, what was the host name? I mean, the host name is not that interesting if you run it on the local system, but if you have lots of servers, this will make a difference. And you can actually filter for that and see, okay, the type, where did it come from, when did it happen, and get all of that information. You can search for stuff, so I'm not sure if I've rebooted my machine, but if you had rebooted, you could simply search for reboot in the log files. Okay, then there's metric beat. That's very consistently for my timestamps. You can see there are quite a lot of requests here, gathering all the system stats I have. And if I expand one of these, you can see, okay, this is a metric set. It has lots of system metrics. For example, there are system-wide metrics, and then there are process metrics and all of these differentiators. So you can see, okay, CPU usage, CPU time, memory usage, and if you find a different set, okay, these are all memory, somewhere should be something about I/O. If we scroll down enough, we might find some I/O, or maybe not. But yeah, you have lots of different metrics there. And then in Visualize, you can simply either build your own visualizations, or since I'm lazy, I have imported the existing ones. So for the beats, there are predefined visualizations that make sense for these metrics. For example, CPU usage per process. And since I've zoomed in quite a lot in that window, it doesn't display as nicely as it should. So if you make that smaller, it fits perfectly. If you zoom in, it gets a bit bigger. So you can see we have lots of stuff running. Mainly Java is sucking up my CPU. So Java is Elasticsearch and Logstash since it's JRuby. And then you see, okay, metric beat is using also a bit of CPU, and Node, the Kibana app, is also using something. Packet beat, not so much. And Filebit is negligible, I think. Yeah. So you can have all the different parts and pieces that are running on your system, and you can see, okay, probably something happened here because Java used more CPU than previously. And you have all the different visualizations for you, yeah, or many that make sense. And then you have the dashboards. And in the dashboards, again, you can either put together your own visualizations, or you can use the predefined ones. So for example, for the metric beat, I'm just getting an overview of my system. So here I have the system load. Since I only have a single server, I just have one entry here, but you would have all the servers you're monitoring displayed here, and you could narrow down the search just to one specific server or multiple ones, and then just get the details from that one. And then you can see the usual stuff you would be expecting. So these are the processes running. This is the CPU usage. This is the memory usage. Yeah, how is your disk holding up? What is your file system doing? And then again, you can see the per process visualization. So Java is also using up lots of memory. Node as well. Packetbeat is also doing some stuff, but yeah, much less. And other things you can just see, for example, HTTP should give us something. So all the requests both to Elasticsearch, since they're just REST calls, and all the calls to Kibana should be here. And you can see, OK, here I've obviously had a peak. I had 59 requests just in those 30 seconds. And in total, in my currently 15-minute time frame, I've had 69 calls in total. My top URLs were all 200 codes, so I didn't have any errors. So yeah, too bad I didn't have errors, because then I don't have anything to show off here. And you can actually see like which URLs were requested most of the time. And this is nothing specific to Kibana or Elasticsearch. This is just HTTP headers and parsing of HTTP headers. And our stuff understands different protocols as well. I don't have any databases installed. For example, if you have MongoDB, MySQL, or other stuff, these protocols are understood by default as well. And just for MySQL, for example, it would then know, OK, the top queries you issued were those. Those were the slowest queries, or those queries took like that amount of time. So all of these informations can just be extracted from the headers, and you don't need any other agents. You just need the Packetbeat to actually monitor the network interface. OK. So since we still have lots of time, and you're an ops audience, I guess we can quickly jump into the configuration so I can actually show you what this stuff is doing. So my system time should be up to date. Just to give you an idea how easy it is to work with the beats. All the beats have their own directory. For example, Filebit will have its configuration in etc Filebit. And if you go to the configuration file, it's all YAML. Oops, that was me and being stupid. VI is your friend. What I'm doing here is, so Filebit is inspecting files, and I'm telling it, OK, there are log files, and I want to ingest all the files in var log whatever log, and var log syslog. And yeah, for Windows, it would look something like this. Just don't use Windows and be happy. And then I'm telling it, OK, once you have received or you have ingested that data, forward it. For example, to Logstash. So I'm telling it, Logstash is running on localhost port 5044 and only communicate via an SSL certificate or TLS certificate. So the connection is actually secured and you don't have any security issues. So the idea is kind of you have lots of servers wherever you want to have them. You put the beats on them. They will grab all the data from the servers. They will use the TSL certificate just to forward stuff to a centralized Logstash server, or probably multiple ones. These will then do the parsing and insert the data into Elasticsearch. And you would just have a few central Logstash servers, and they are pretty much right in front of Elasticsearch, so then you can probably skip encryption for them. But you assume you have all the beats out somewhere, and you want to secure those connections. So for those of you who haven't yet seen how Logstash is configured, you always have three parts for the Logstash configuration. So here my log files are coming in. So the first thing is I have a configuration. Some stuff is coming in via beats. So all I'm telling it here, like, OK, Beats will send you something. This is the port you would need to be listening on. Yes, use SSL. This is your certificate, and this is your key, and only do communication via this key pair. The next step then is, once you have ingested or received that data, you actually want to filter or parse it. And here I am telling it, if the thing I'm getting is of the type syslog, I will do grok. And grok is just like grep, so regular expressions, and you're parsing the log message you've received into the different parts so you can actually extract the timestamp and know from which file stuff came from and have all the different data you have in whatever log file you have. There are many patterns you can just find on the internet for well-known log formats. So for example, as long as you have an HTTPD server or Nginx, HA proxy, probably the default Tomcat logs and all of these things, you will find patterns. If you have a custom log format, you will need to write your grok patterns yourself. Might be a slight pain in the beginning, but yeah. It's regular expressions you will manage. And the final step then is, once I have parsed everything, I actually need to tell Logstash where to store the stuff. And here I'm just saying, okay, forward it to Elasticsearch directly. The Elasticsearch instance you're talking to is running on localhost 9200. And this is the index. So you have something called whatever Beats name you have, take that and append the current day as a timestamp, so you will have one index per day. And if you at some point decide I don't want to, or I don't need the logs for that specific date, you can simply drop the entire index and get rid of all of that stuff. So of course you could configure that to be only create one index per month or whatever, but here you can see how it's working. And I think you're getting the idea. And for the dashboards, there's basically one configuration or one dashboard predefined file. You can simply import from the installation you get with each beat. So you can simply have that in Kibana. I assume everybody knows Sense, or now it's called Console. If you're getting started with Elasticsearch, this is the sanest way to do anything. So you have whatever you want to do, you just write get, post, put, delete, the endpoint you're targeting, and you can run everything in here. And you can see, okay, my current cluster is named Dust. It's the latest alpha version. And yeah, you know for search, and it's running Lucene version 6.00. And whatever query you want to define, you have auto-completion and syntax highlighting here, so this is by far the easiest way to get started. And then there is Timeline. Timeline is also pretty new. And you can still see here, it's written research. So Timeline, there are no releases for it yet. It's just a preview, and Rashid, who also started Kibana initially, is now working full-time on Timeline just to create the best time series experience we can build. So what it does is you simply have specific syntax to query data. For example, .es whatever will just grab all the data you have in your Elasticsearch cluster and display that. If you, for example, want to limit that to something like Filebit, you can say, okay, I want only the information from Filebit. And obviously, I didn't ingest many files. To add more metrics, you can simply say, okay, let's see. I want to add packet beat as well. But that doesn't sound like too much fun. So let's add metric beat as well and see who is producing most messages. Obviously, it's the yellow thing, and you have no idea what the yellow thing is. So let's see. I assume it's this one. So you can say label metric, and you can actually label these. If you don't screw up, you can actually see what it is. And you can see, okay, obviously, metric beat is producing lots of stuff, and you can hide and show specific metrics, and you can just get to work in here. And what is particularly nice about Timeline is that you can also grab or get data from external sources. So for example, there is the World Bank who provides information. So for example, if you know how many Germans there are in the world, you can simply grab that data from the World Bank. However, we want to have that per year, and we probably want to switch to something like 60 years and not minutes. Otherwise, that would be confusing. And you can see, okay, yeah, there are lots of Germans, obviously. And then you probably want to know, like, okay, how many French people are there? Like, okay, let's see. And then you can actually see, okay, the population of Germany, yeah, it was much bigger, but actually the French are kind of catching up. So maybe at some point there will be more French people than Germans. I don't know. And you can actually then wrap that in functions. So yeah. So if I want to have the derivative and see how stuff changes over time, you can actually see, okay, the Germans, sometimes they are growing, but sometimes their population is actually shrinking, whereas the French are pretty constantly growing. And I don't know, whatever weird data outlier we've had here. I don't know. That's World Bank data is probably not totally reliable, but that's it. Okay, so to conclude, we have now, there was the Elk stack, now it's the Elastic stack with Beats, the lightweight agents to ingest stuff. There's Logstash to do the heavy lifting. Logstash is not going away, it's just like not doing all the things anymore, but they're just different pieces it's still doing, and it will be around. And there are, for example, if you need to get stuff from various different sources, and you need to aggregate them and do complicated lookups, that is still what Logstash will do for you. Then there's Elasticsearch to store your stuff, and Kibana to visualize and graph it. And if you want to give it a try, it's a Vagrant box. Get the code, run Vagrant up. It will configure everything for you. You can, depending on your download speed, it will be probably up in like 15 minutes, and you don't really need to do anything, and you can just start playing around with it. And I will keep the box up to date. So this week, Alpha 3 was released. As soon as the next Alpha or Beta comes out, I will update the box, so you can always have the latest and greatest. And yeah, please rate the talk. Any questions? And yeah, I have lots of stickers. I will give away some stickers. So for all the products, we have stickers. Any questions? Sure.
Beats is a little bit new, right?
Beats is...
So it's quite new. Is it still in beta or is it out of beta?
Current version is 1.2. And it will go right away to version 5 as well.
But it's stable.
It is stable, yeah. There are releases. I mean, there was TopBeat. With version 5, TopBeat will be changed to metric beat. So it is probably not as evolved as the other products, but it is stable, and people are using it. And it's gaining lots of traction because you don't really want to put Logstash on all your servers. It's just too heavy. So there's a real need for Beats, and yeah, we're seeing really good traction. And we're kind of pushing in all directions and trying to replace other systems with it. Any more questions? Yes? Wait for it.
Will Beats cache the queries sent to Logstash or the saves to Logstash? If the connection between Beats and Logstash is broken, will it cache the content?
For Beats, there are two modes, depending on what kind of data you're actually trying to send over. With files, it's pretty easy. Beats notices, okay, the other side, either you're talking to Logstash, you're talking to Elasticsearch directly, or you could also put a queue in between. So whatever happens, if the other side you're talking to is not available, with files it's easy. You just like remember, hey, I sent everything up to here and I'm stopping. And as soon as the other side is available again, I will just send everything after that. With the other metrics, which are not stored on disk, it's not that easy. So for example, for the metrics or the packets, there is a buffer. It will be filled up, but as soon as the buffer is full, the oldest data will be thrown away. So yeah, depending on your use case, plan for that. With Logstash, probably you want to have more than one instance if you're writing directly to Logstash. Otherwise, if you have a Kafka queue and that's highly available and can ingest or keep enough data for you, that's also saving you butt.
All right, then we're running out of time, so thank you, Philipp.